Engineering solutions. Shunt versus multiplier. If you have a very high current and you want to measure using a galvanometer, you know, a galvanometer is used to measure small amount of current. But in this case, you have only a galvanometer, but you want to use it to measure a very high current. It is possible to use a galvanometer to measure a very high amount of current. You just need to connect what we call a resistor, but this resistor should be a very, very low resistor. You connect it in parallel with the galvanometer, so that the galvanometer, assuming it is giving a full scale deflection, that's the maximum limit of the galvanometer, say 20 milliamps, and I want to use this same galvanometer to measure a current of say 10 ampere, then I need to connect in the circuit a low resistor in parallel with the galvanometer, in order for the galvanometer to now give a full scale deflection of 10 amperes. At first, the full scale deflection of the galvanometer is around 20 milliamps, and I want to use it to measure a current of 10 amperes. Then connect what we call a resistor, but this resistor should be very, very low. Now that resistor that you will connect in parallel with your galvanometer, that resistor is what we call the shunt. So the shunt is a very low resistor connected in parallel with a galvanometer, in order for the galvanometer to now give a full scale deflection in amperes. At first 20 milliamps, want to use it to measure a current of 10 amperes, then we need to shunt the galvanometer. That resistor used there is called a shunt. The other way around, if I want to measure a very high voltage, I don't have a voltmeter on me. Within the circuit, I can also connect within the circuit a very high resistor, and this resistor will be connected in series with a galvanometer. So assuming this same galvanometer that gives a full scale deflection of 20 milliamps, I want to use it to measure a voltage of 5 volts. Then I need to connect a high resistor in series with the galvanometer. Now the galvanometer will now give a full scale deflection, but now the reading will be in voltage. So that type of resistor used in the circuit, that high resistor used in the circuit, in order for the galvanometer that gives a full scale deflection of 20 milliamps to get a voltage reading, is what we call a multiplier. Okay, so let's do some calculations on it. So assuming I have a circuit like this, and have a galvanometer giving a full scale deflection of say 20 milliamps, and now I want it to read around say 10 amperes. So there is the galvanometer, and the galvanometer is having a resistance. So let's say RG here. This is my circuit diagram. Okay. Now the current coming in is 10 amperes. So this is the total current entering I. The galvanometer has a full scale deflection of 20 milliamps. But now I want this galvanometer to give a full scale deflection of 10 amperes. Now to do so, I need to connect a resistor which is very low in parallel with the galvanometer. So I'll call this resistor of the shunt. That's what we call the shunt resistor. There is it in parallel. Now, let's say the galvanometer has a resistance of say 8 ohms. Now, when the current reaches this junction, the current is going to split according to Kirchhoff's first law. So Kirchhoff's first law, the current is going to split into two. The current that will pass through here, I'll call it Ig, the current through the galvanometer. Then I'll call here Is, the current through the shunt. Okay. So from theory, we know that the total current flowing through this the circuit, I equal to Is, the current through the shunt, plus the current through the galvanometer. The total current entering now is 10 amperes. So I have here 10. The current of the shunt, Is, is unknown, plus the current of the galvanometer. The galvanometer gives a full-scale deflection of 20 milliamps, which is equal to 0.02 amps. So 0.02. Making the current of the shunt the subject, I'll get 10 minus 0.02, which will give me 9.98 amperes. Okay. Looking at the circuit diagram, the shunt is in parallel with the galvanometer, meaning the potential difference across the shunt is equal to the potential difference across the galvanometer. So PD across shunt is equal to the potential difference across the galvanometer. Okay. So PD across shunt, we know from Ohm's law, potential difference V is equal to the current times the resistance. So the potential difference across the shunt, Vs, is equal to the potential difference across the galvanometer, Vg. Vs will be Is times Rs. Vg will be Ig times Vg. Okay. Oh, sorry. Times Rg. So I want to find the resistance of the shunt. So that low resistance Rs will give me Ig multiplying Rg over Is. So Ig, the current of the galvanometer in full scale deflection, is 0.02, multiplying the resistance of the galvanometer 8 over the current of the shunt, that's 9.98 ampere. Okay. So that will give us a final answer of 0.016 ohms. So this is the low resistor, the shunt, 0.016. So when you connect this 0.016 in parallel with the galvanometer, then the galvanometer, instead of giving a full-scale deflection of 20 milliamps, is going to give a full-scale deflection of 10 amperes. So now we are using the galvanometer as an ammeter to measure a very high amount of current. And that resistor connected in parallel with the galvanometer serves as what we call the shunt. Okay. Let's look at the multiplier. The multiplier is a resistor, but here we are using it in the circuit. We are connecting it in series with the galvanometer. So connecting the resistor in series with the galvanometer will make the galvanometer rather give a full scale deflection, and now the reading will be in voltage. So I have another question on multiplier calculation, where I'm going to connect now still 20 milliamps, but now I want you to read around, say, I'll give it 5 volts. I want the galvanometer to give a full scale deflection of 5 volts. Okay. Now, from the same principle, Kirchhoff's first law, when the current enters, it is going to split like this, IS and then IG. But now here will be, I'm connecting a new resistor called the resistor of the multiplier. I'll connect it in series with this. So I'll call this will have a resistance Rm for the multiplier. Okay. From theory, if resistors are in series and current is flowing through them, then the same amount of current is going to flow through the two resistors. So the current through the galvanometer will be the same as the current through the multiplier, meaning I of G is equal to I of M. And we know that galvanometer gives a full scale deflection of 0.02 ampere or 20 milliamps. Okay, this one. From theory, Ohm's law, we know that voltage is equal to current times resistance. So if I want to find the voltage of the multiplier Vg to be the current Ig times the resistance Rg, but I don't know Rg. If I want to find, I know Rg, that's 8, and then Ig 0.02, so that will be the voltage of the galvanometer. So I 0.02 multiplying my resistance 8 ohms, which will give me 0.16 volts. Okay, the total voltage across this circuit V, the total voltage V, because the resistors are in series, will be the voltage across the multiplier plus the voltage across the galvanometer. Total voltage that I want to measure is 5 volts. So 5 equal to voltage of the multiplier, which I don't know yet, plus the voltage of the galvanometer, 0.16 volts. So I'm getting the voltage of the multiplier to be 5 minus 0.16, which will give me 4.84 volts as the voltage of the multiplier. To get the resistance of the multiplier, you know, from Ohm's law, this equation, V of the multiplier equal to I of the multiplier multiplying the resistance of the multiplier. So the resistance of the multiplier becomes the voltage of the multiplier over the current passing through the multiplier. Voltage of the multiplier is 4.84 volts over the current of the multiplier, which is the same as 0.02 amps, but they are arranged in series. So 4.84 divided by 0.02 will give us 242 ohms. So that is the resistance of the multiplier. So the resistor that we connect in series should be a very high resistance, should get a very high resistance in order to make the galvanometer gives a full scale deflection of 5 volts. So the final answer is 242 ohms. This resistor used in the circuit is called a multiplier. a resistor used in a circuit connected in series with a galvanometer, but this resistor should be of high resistance in order to give the galvanometer a full scale deflection, but here should be in voltage. That's the difference between the multiplier and a shunt. A shunt connected in parallel with the galvanometer to give a full scale deflection, and this full scale deflection will be in amperes. But for the multiplier connected in series, there should be a resistor with a high resistance. When you connect it in series with the galvanometer in the circuit, immediately the circuit is closed. The galvanometer is now going to give reading in voltage. The full scale deflection in milliamps at 20 milliampere will now give you 5 volts as its full scale deflection. So that resistor that you use in connection with your galvanometer is what we call the multiplier, but it should be in series and it should be of high resistance. So that's the difference between a multiplier and then a shunt. See you next week for another topic. Thank you. Please make sure you subscribe to Engineering Solutions, the only solutions with a Z. Thank you. Bye bye.